SDN. What is SDN actually? SDN is automation. Why? How we can automate the network devices? We can automate the network devices. How? Because if you are talking about a small network, we have couple of switches and routers. We can configure it manually. Think you are working in a data center. We have 100 switches to configure. So to configure all these switches manually is not an easy task. It is a time-taking task. Afzal, can you hear me?
Yes, yes, yes.
Okay. And the same time, when we are configuring manually, there's some chances we can miss something called as configuration drift. We can miss some configuration. We can in manual configuration you can say human errors. Then again, it becomes difficult to configure, and this configuration task involve many people, more time, and also more cost is involved in that. So to overcome this problem, this some concept of automation has been introduced in the network devices. The concept here is very broad, but actually we are going with the just basic concepts of automation in the CCNA. There is no implementation as well. Just will try to understand what automation is, how it's going to work. But in CCNP we have installation and configuration of the network devices with the help of the SDN. But if we talk about SDN is basically software defined networking enabling organization to accelerate application deployment and delivery, dramatically reducing the IP cost through policy enabled workflow automation. SDN technology enables cloud architecture by delivering automated on-demand application delivery and mobility at scale. In network architecture is a network architecture approach that enable a network to be intelligently and centrally controlled by a program or a software application. SDN was originally created to decouple the forwarding function from the networking equipment, to decouple the control from the forwarding function. How it can work? If we are configuring a device, a switch or a router, take an example of a switch. We have configured inside port security, VLAN, VTP, everything we are configuring. How the device will work? Actually, this we say in the box we have a three separate function. These are one part is called as management part, called as management plane. Second is called as control plane. Third is called as data plane. So we divide this box into three different functions. This is one control plane, one data plane, and one management plane. So this way we remove management and control plane from the box and give it to the application or a software, and data plane resides in the device. So this way we can configure the device with the help of the some software application. So this way creating, for example, what is the task here? All these three tasks are separated by the different planes. Control plane is a basically is a control responsible for exchanging routing information, building ARP table, and learning MAC address, build MAC table, run spanning tree, create loop free topology, running routing protocol, to build the routing table. This all function of the control plane. When we talk about the data plane, the data plane is responsible for forwarding the traffic. It relies on the information that the control plane supplies. Here the some task of the data plane takes care of. How the traffic will flow according to the routing table, according to the VLAN configuration, according to your port security. So how the configuration provided by the control plane, data plane function in the same way. So whether it doesn't matter if the data control plane is in the box or outside the box. This doesn't matter. So this what exactly the data plane is. Data plane is responsible for enabling for responsible for forwarding the traffic. It relies on the information provided by the control plane, like encapsulation and encapsulation of the data packets, adding and removing headers, dot one q header, matching the MAC address for forwarding, matching IP and destination and IP destination in the routing table, changing the source and destination MAC in case of NAT, deploying the traffic, dropping the traffic in case of access list configuration. The task of the data plane have to be performed as fast as possible, which why we the forwarding traffic is performed by specialized hardware, which we use the specialized boxes, which is manageable switches, manageable routers, high-end configured device, because they have special hardware. They can perform data forwarding at a very high speed. Okay, then the next part is basically the management plane is a use for to access and manage the device, network device, like for example using telnet, connecting console port, accessing the device. After connecting and configuring the device, you disconnect the console port, you disconnect the telnet session, but you still your device is working. So we can also remove this function from the device. So this man- management plane is used to manage the devices. For example, accessing the device through telnet or SSH or console port. The concept of SDN is very broad, and every open source provider and commercial vendor takes in a different direction. With SDN, we can use a central controller for the control plane. It may be the physical hardware or the virtual machine. There are two type of interfaces in SDN. There are two type of interfaces. One is a northbound interface and a southbound interface. You think there's a SDN controller. SDN controller has a two interface. One interface connecting towards the application. One other interface connecting toward the devices. The application deliver configuration to SDN controller. SDN deliver the configuration to the devices. So this way we have a two interface in the SDN controller, southbound and northbound. SBI and NBI. A northbound interface is an interface that allows a particular component of a network to communicate with the higher level of component. Conversely, a southbound interface SBI allow a particular network component to communicate with the lower level of component. So northbound, lower level means devices, switches, routers. Higher level means application. The northbound interface is used to access the SDN controller itself. Northbound interface is used to access the SDN controller itself. This allows a network administrator to access the SDN, to configure it, or to retrieve information from it. This could be done through the GUI and also offers an API. Allows other application to access the SDN controller. You can use this to write a script and automate the network administration. Here is some example of the SDN is list information for all network devices in a network. I want to list all information for all network devices. One task you can explain like show the status of all physical interfaces in the network. Add a VLAN to all the switches. Show the topology to the entire network. Show the topology of entire network. Automatically configure IP routing access list when a new machine is added. These are the tasks which can be automated by the SDN. Okay. A user that is using a GUI to retrieve information from the network from SDN controller, behind the scene GUI is an API. A script that is written in the Java or Python and can use the API to retrieve the information from SDN controller or configure the network. Okay, the SBI, the southbound interface, the SDN controller has to communicate with our network devices in order to program the data plane. That is done through the southbound interface. That is not a physical interface but a software interface offers an API, application programming interface. An API is a software interface that allow an application to give access to other application by predefined function and the data structure. The API is a software interface that allows an application to give access to other application by using a predefined function and data structure. The southbound, some of the popular southbound interfaces are OpenFlow, This is a probably most popular SBI at the moment. It is an open source protocol from Open Networking Foundation. This is one organization who built this controller, OpenFlow, and there are quite few network devices and SDN controller that supports OpenFlow. But another one is a Cisco Offlex. This is an answer, Cisco's answer to OpenFlow. It is also an open source protocol which has been submitted to IETF for standardization. So Cisco has its own Offlex. See, also the CLI Cisco offers APIC, which is an SDN solution for the current generation of routers and switches. It uses a protocol that are available on the current generation of hardware like Telnet, SSH and SNMP. The advantage with the Cisco Offlex, it can use our devices with the help of the same CLI configuration as we used to use. Open Daylight is it's an open source SDN controller hosted by the Linux Foundation. This by the Linux. So Cisco has an advantage. Cisco SDN controller is an APIC application policy infrastructure controller designed to manage the data center. Cisco SDN controller is a DNA center. It is designed to manage the enterprise environment. DNA stands for Digital Network Architecture. Cisco DNA Center is a complete software-based network automation and assurance solution. It is a dashboard for control and management of Cisco intent-based networking. Intent-based networking relies on the artificial intelligence and machine learning to prescribe and perform a routine task, set policy, respond to a system event, and verify that goal and action have been achieved. For example, you have written a program. One interface goes down in a device, you see some message appears, no? This interface is down. I copy that interface and I paste into the program. I see when you see this message, just go to the box, enable config T, interface FS01, no shutdown. Automatically, when the program see this message, it will run this command set of commands and your interface will come up automatically. So this way, no need to check, no need to know people inform you we are not able to access this specific network. No, network will do automatically. So this is done like artificial intelligence. When they see this message, on the basis of the specific message received, we use this message in the script. When software see this message, they run a set of commands so that it automatically make the interface up. REST API. REST to interact with the application or the network devices, we can use an application programming interface API. API is a software interface which allow other application to communicate with our application. REST API, representational state transfer. REST stands for representational state transfer. REST API. Northbound and southbound interface use an API. Let's take a closer look when an API. What is an API? SDN controller typically uses a REST API. Okay, REST API uses HTTP message to send and receive information between the SDN controller and other application. It uses the same HTTP message that you use when you browse a web page to the internet on the internet or when you enter some contact form online. HTTP GET when is used when we want to retrieve information. HTTP put or post when we want to upload or update the information. Same HTTP command, but it's similar to browsing a web page, only this time we are not requesting a web page or a picture but a particular object from a SDN controller. Like when the SDN controller receives the HTTP GET request, it replies with the HTTP GET response with the information that was requested. This information is delivered in the common data format. The two of the most common data format is JSON and XML. So JSON stands for JavaScript Object Notation and XML stands for Extensible Markup Language. Okay. If you see a picture here, we have an image, a Python program running a script connecting to SDN controller. We have a script here. If you can see this HTTP GET URL. The above we have a Python script that is using HTTP GET to fetch the URL through an API. What this command is, the URL will retrieve some variable that are available, for example information about all nodes on the network. So information about network node. So once the API is received. Once the API receives this, it will respond with the HTTP GET response message, and it will say HTTP GET response message from the SDN controller, and the variable that were requested will be supplied in the JSON format. In the JSON format, here is how it looks like. It starts with the curly bracket, nodes, square bracket, curly bracket, IP and IP address, MAC and MAC address. So we see this one IP and one MAC, and also another IP and another MAC. So here we have never seen the JSON, but it's easy, we can understand this what is program. The output says we have a two nodes, their IP and the MAC address. Very simple. Here, even if you have never seen the JSON before, the output above is easy to read. It tells us about the information. We have the two nodes on network, their IP and the MAC address. Interpreting JSON, there's a key value pair. This program has a key and value. Every key has a value. Key before the colon, value after the colon. So IP is a key and IP address is a value. Same MAC is a key, so MAC address is a value. So here we have each and every column identify one key value pair. Key before the colon, value after the colon. With the key before the colon, keys each and every column identify one key value pair with the key before the colon, value after the colon. Key is the text inside the double quote before the colon used as the name that refer to the value, and value the item after the colon that represent the value of the key, which can be in the double quotes or in the text or numerical. Okay, what is the array and object? Array is the surrounded by the square brackets, and objects are surrounded by the curly brackets. So these are the four fields here. We have arrays, we have object. So they show this script in the exam. They ask you how many key value pairs are there, how many arrays and objects are there. So you have to count the pair of brackets. Square bracket one pair. So it means it is one array. How many pair of curly brackets? Then many objects. How many key value pairs? So you can count. You can see the program, and this will be the question they ask in the exam. They show one sample script. They ask you about arrays, about objects, about key value pairs, like this. Okay, a JSON string contain either an array of value or an object. An object associated array. Okay, array is surrounded by the square brackets and contain a comma separate list of values, and objects surrounded by the curly brackets. Okay, software action. Then this is nothing new. This is just an action what we can perform on the application, on the data. Software action like CRUD. C for create, R for read, U for update, D for delete. So means create allows the client to create some new instances of variable and data structure at the server and initialize their value as kept at the server. Read allows the client to read the current value of variable that exists on the server, storing a copy of variable structure and value at the client side. They cannot change in the server side because just a read. Update allows the client to update the value of the variable that exists on the server, and delete allows the client to delete the value from the delete server. Allows client to delete from the server different instances of the data variable. So these basically four software action: create, read, update, and delete. It depends according to the permission which client has. Then configuration management tool. Configuration management tool is important because it allows us to scale infrastructure and software without having the scale staff to manage our systems. What are the features in configuration management tool? We have, on the high level, configuration management tool offers the following features: enforcement, cooperation, version control friendly, change control, abstraction layer. What they are actually? We see what is enforcement. By using a tool, configuration management tool, to configure our devices, we ensure that the device is configured to the desired state. This prevents configuration drift. Configuration drift happens when people manually install package or change the configuration files. Configuration drift makes troubleshooting time consuming and difficult. So enforcement, as you connect any new device, all the configuration will be delivered to that particular device. Like enforcement is automated. No need to do anything in addition. Is automatically implemented. Like when you join a client to the domain, all the domain policies applied to the client. Simple way. So it's already designed. Enforcement, cooperation, storing configuration in a common configuration management tools make it easier to cooperate with others. Having all configuration files in a single place make it easy to roll them out all required systems to all required system and share them. Basically cooperation, because we are sharing all the files together in the same place. Okay, version control friendly. Having all configuration file in a single place means we can put them under a version control system VCS like a Git. This is a great cooperation for cooperation, since multiple people can work together on the same file. Everyone can see who added or edited which file and when. Even we can use the previous version of file if you want. Some file has been edited for new configuration yesterday, but you want to deploy some previous configuration, you can see even previous version. You can deploy that one as well. That is a version. That is a benefit of version control system. Change control. Not like a backup. Backup is something else. Configuration. You have a configuration file. If you edit, it is changed. Previously removed. But no. Configuration management tool. It will keep previous version. You can see. You can see this is edited yesterday by this person. And you can, if you want, you can use previous one because you have installed that one before. You know that is working good. So you can install that one. So this is all because visibility is there. Who changing, what they are changing, and the information is available there. Change control, because configuration management tools are text based, we can put them under version control. With the VCS, we can easily change. We can easily see the changes between the configuration files, and which makes code review simple. This makes it easier to decide which configuration to push the production into. And abstraction. What is abstraction? Abstraction is a layer which keeps your configuration separate from the base operating system. Like even if you use a Linux, it is possible that you use multiple distribution like Ubuntu and CentOS. There are difference between this distribution. Installing packages require different command, and the location of the files can be different. For example, the Apache web server uses a different file and folder on CentOS and Ubuntu. Configuration management tools abstract these operations specific items away for you. You can use the same configuration files without worrying about the underlying operating system. So this is also facility. Abstraction is there. Your file don't get mixed with the operating system files. Okay. The two type of tools, agent versus agentless tool. Agent based tool and agentless tool. The two type of tools are available, agent based and agentless. Agent based tools requires installation of agent on the system you want to manage. Agentless tool don't require an agent software on the system you want to manage. The Puppet and Chef, there are two common tools which are agent based tools, and Ansible is an agentless tool. So we are using Ansible nowadays. Is agentless tool, easy to manage. Okay, they ask all in the exam. Puppet, Chef, Ansible. Okay, what agent based, what agentless tool. Now Puppet is a basically configuration management tool used for deploying, configuring, and managing the servers. It uses a master slave architecture. There is a Puppet master on the client. We run Puppet agent that pulls the configuration from the master. Puppet calls configuration file manifest. Just keep this mind, this name, configuration file name. Puppet calls the configuration file name manifest. They will ask you which name is used by which management tool. So Puppet uses this configuration file. They call it a manifest. Manifests use Puppet's own specific language called domain specific language. Also the name of the language used. Puppet DSL is known as Puppet DSL, domain specific language by the Puppet. And the configuration files are known as manifest. Then Chef. Chef is another automation platform that configures and manage your infrastructure. On the every each and every device. Each and every device you have to install. Then only we pull the configuration. So this is again, previously we were using, but with the Ansible, this advantage that we don't use Puppet anymore. Chef is an automation platform that configures and manages your infrastructure. It uses a master-slave architecture similar to Puppet. The Chef servers manage the nodes and store the configuration for the nodes. Each node runs the Chef client and pull the configuration task from the Chef server. Chef calls configuration cookbooks. So also memorize this name. Chef calls the configuration cookbooks, and Chef uses its own DSL, Ruby DSL. So this is used by the Chef. The user create, test and maintain the configuration or policies on the workstation. We push these to Chef server. Chef uses the Ruby DSL configuration files. Then Ansible is a latest tool we are using. Ansible is a configuration tool and orchestration tool written in Python, so which uses yet another markup language, YAML. YAML is used by the Ansible, and YAML is a human readable data serialization language. It commonly used for configuration files and application where data is being stored or transmitted. For configuration task, we call these tasks playbooks. So Ansible call configuration playbooks. Ansible calls configuration playbooks. Ansible is agentless, uses SSH to connect nodes. It sends program called Ansible modules, run them, remove them when finished. So this, for the future, if you want to be in the network, you have to study Python and Ansible is important. Ansible is a great way to get started with the network automation. Playbooks are easy to read and write, and since agentless, we don't have to hassle of installing the server on the and agent on the nodes. That's it, little introduction in the SDN. I hope it will solve the purpose.